So the AI will be an assistant instead of the worker.
Yes.
Yeah, what I wanted to clarify is that you said that it can automate, I don't know, based on environment variables, give it the strength of the material or the, I don't know, the strength of other things or the maximum transfer, degrees that may be possible. What do you think makes a human so unique that the AI cannot replace him in part of, I don't know, material, shape or designing parts in particular?
I believe that generally AI will not be able to replace humans. I mean, our brain is like an ultra processor, a supercomputer. We realize things when we learn anything. We learn things that cannot be understood even by us. We learn things in our background. Our brain may do background tasks. Generally, our brain is not something that we understand, but we at the very least understand that it cannot be replaced easily. It conceives things, it creates ideas that even we never believed. That's what happens with science. Every time there's a new breakthrough that we thought was impossible, even in the past. That was only possible because of the power of the brain. I do not believe that the processor will be able to replace that.
Yeah, but the human brain can make a lot more mistakes. For example, about 30 to 35 years ago, we didn't think AI could beat a human in chess. Because chess is a game of intelligence. I think we can all agree on that.
Yeah, no, that's pretty interesting. But what I think you're saying about us being inefficient, look, there is always human error. In every study we do, we always have a percentage of the results accounted by human error, because we can never be perfect. That's why we are human. But surely AI will help us, mitigate that human error in a sense, because it can check about conclusions or theories we may have without any emotions attached, meaning that it can actually run calculations again and again and again under circumstances where we know it's least possible to be for errors to be made, and check maybe conclusions or theories or help us achieve more new breakthroughs. Not necessarily do the breakthroughs by itself, but assist maybe in the discovery of them.
Do you think there will be a time where the AI can code itself better than its owner, making an infinite loop of the
So
AI?
that the theory you are talking about, it's called singularity, meaning that an AI will be so advanced that it can make Nobel-winning breakthroughs every 5 seconds or something. That's pretty interesting to consider, because we don't yet know completely how the brain operates or how thinking or creativeness operates. It can surely, in my opinion at least, make breakthroughs based on things we have not considered before, like looking at data from another aspect than we do, maybe because we are charged with emotions or because we think things might just be impossible. It might help with some novel discoveries in that sense, but at some point, I don't think that AI has the creativity of being a human. So yeah, it will basically come after us and clean up things that we have already discovered and helps us, help us make breakthroughs on that. But I don't believe it can make new breakthroughs on topics we have not yet reached.
Yeah.
That's a great example of that is the creation of of the blue LED. So the way the wavelength is through material, for many years it was thought that the creation of a blue LED was impossible. A human, which I cannot remember his name, went back and looked at all the studies and basically tried to create a material that thought it was really, really bad and inefficient for LEDs. But he looked at it another way and modified it in a way so the wavelength could be what we needed to create blue LEDs. It's a really interesting story.
Okay, that's so interesting, though. I didn't know about that. And this, of course, advanced human technology hundreds of years.
Yeah, look around you. I mean, the laptop from the guys back at the productions, it's the robots, the LCDs on the robots, the control hub, the driver's tab on Rev Robot, all sorts, are the labs we code on and Duke had. It's all based on that one singular discovery of glue LEDs, allowing us to make every color in the spectrum. It's really interesting how one small discovery that once was thought to be impossible can really, change the world in a sense.
Yeah, that's so interesting. I didn't know about that.
From what I understood, this was discovered by backtracking essentially and recreating something that was not efficient, but it could do the job.
Yeah, so for many years, the first LED that was discovered was the red LED, and some years later the green. But because of the very difficult atomic structure a material should have in order to emit blue light, it was thought for many years that LEDs would only serve as indicators in machines, like, this thing is on, this thing is off, this thing is on that percentage. Not that it could actually create every color of the spectrum. It was very limited. And people were there were two materials see fit to basically create the crystal that needs to polarize that power and make it blue, basically the blue LED. And one of them was disregarded pretty early on because it was not looked deeply enough and it was just thought of difficult. And a Japanese scientist at some point was, why don't we look at that? We had not examined every single aspect of this material. It could, and as it's so later, it could and actually did create the blue LED, which is responsible for many revolutions up to this day.
Yeah, that's so interesting. Now, I love when sciences collide. For example, on your example, chemistry and computer science collide.
And electricity, yeah.
Yeah, it made something beautiful. I loved when two different fields of study collide and make our life better.
Yeah, no, that's the meaning behind STEM. I mean, it's not only one science, it's science, technology, engineering, it's art, now with STEAM. Meaning that not one singular science cannot make a great breakthrough, but multiple of them combined together can surely help us, go forward.
That's so beautiful. Sometimes theoretical scientists and practical scientists can work together. For example, the integer I, the root of -1. No one thought this could have a use, but it is used in everyday robotics, everyday computer science. It's one of the most
Used.
It's one of the most used integers in everyday life for.
Yeah, for many things dating back to, basically the usage of computers. It's a pretty interesting thing. So, what's a breakthrough you've heard of, studied maybe that thinks it combines a lot of sciences and helps us in the great?
Actually, a very recent breakthrough would be SpaceX with the rocket that they managed to catch a rocket with arms over the sky.
Yeah, of course.
Yeah, this was a combination of very heavy mathematics, physics, and chemistry in order for them to, be able to manufacture, of course, the fuel in order to do it. It was also a combination of computer science that has become, I think, of its own in order to regulate how much fuel.
Yeah, no, it was a feat of engineering. I mean, feat of engineering and science in general, because it firstly, was made possible the Starship was made possible by chemistry and engineering, by the manufacturing of parts. So, yeah, by the material, it was possible to withstand the heat of the thrusters and atmosphere when it came down. And then it was a matter of control theory and basically algorithms similar to ones we use here for FTC to, take care of the job and make sure that this landed next to the tower and not on top of it.
Of course. Now, I think it's wonderful how we use nature itself to make something so large that it can take us to another planet or into outer space.
Not yet. That's pretty interesting, and that connects very well with the question we asked in the beginning. Science and the access we have, young kids, the new generation has the technology, sciences, and all the things from a very young age. Most of them, with first FNL, which is the competition before us, under FTC.
Lego Minecraft.
Yeah, it was from Lego Milestone to Duplo to things and competitions, from first Lego Explore to Discover to Challenge. There are many ways a young child can be influenced and entered into the world of technology, which is pretty interesting because we see that in the past 50 years, so many discoveries have been made from not even having, internet to now NASA, I believe, achieving something of a terabit connection, which is mental, to be honest. Yeah, it is just a matter of time to see how young people will, lead in the future. Yeah, thank you, John. It's in the future of engineering and sciences.
Yeah, I think the evolution of kids now, because I was once an FLL kid.
Yes, Grandpa.
Yeah, three years ago, I was making robots with Legos and Spike. Now it's real metal and 3D printing.
Yeah. No.
Well, that's like
Yeah, that was mind blowing.
Yes, it's a very rapid evolution of AI that children generally have to go through nowadays. So I believe it's really interesting nowadays that we see children going from, as you said, Lego. You were not 3 years ago, you were playing with Legos, and now you're full on creating actual robots that have applications in the real world. Like, for example, last year in FTC, we had the center stage, in which you had to collect pixels and put them on the backboard, optionally creating mosaics. And I believe that we see that robots that we create, as students create, can have real-world application. And now this year with Interactive, we have the samples, we have a couple of tasks.
Yeah. It's pretty interesting because if you take something that actually has a real-world application, we can start to talk about last year's draw that we needed to have on the robot.
yeah, I heard that.
The paper airplane, because that was really interesting. The calculations we had to run for, first of all, the rubber band to do its job. Good goal.
Yeah, that was
yeah.
For 10 points,
For 10 points.
or 15, whatever it was.
Yeah, it was pretty interesting. The whole calculations you had to do for just one thing to go wrong, and the drone launcher to implode in a matter of 3 minutes. Yeah, I know. It was pretty interesting. How it's like this in the real world. Yeah.
Imagine now you work at SpaceX, and once you wonder, imagine you have an error like
26, yeah.
26. It's like you didn't have 3 counts explaining it.
Yeah, we didn't try 5 times to.
Some kind of rituals, should I be scared?
Okay.
76 at the same time.
You have an error class 36, and you work at SpaceX, and the rocket explodes. It's on you. No one will know, of course. But
Oh, you can finishes.
Yes,
Yeah,
35 programmers worked on it. I mean, that number is not fact-checked, by the way.
It's not fact-check at all. Yeah,
that's so round.
Yeah.
probably. They will probably be, somewhere around here, a number saying how many actual programmers worked at Starship.
That many? Oh my god.
Oh, I wouldn't get a sick. Oh, if it doesn't explode again.
Okay, great.
Let's wrap up.
Yeah,
Anything you want to add to the topic of
let's wrap up. Because mostly after, production, how much time has it been rolling the tape? I mean, yeah, it's been 2 hours trying to, compile things for that podcast.
Yeah.
So we need to fact check a lot of things, throw them out the window if they're not correct, some of them, and
and the editing will be a pain, of course.
yes, and actually be able, and actually be able to keep our laughter together because after 2 hours we need to eat and we need to
Thank you guys.
Thank you for having me.
It has been great. This has been your host Thalis Katsimichas with Nousias and George Lepidas. See you next Sunday.
Bye.
But